All right, so let f be this function. What is the maximum value of f on that interval? So we gotta check. We gotta check what. Let's do a table, no? So definitely gotta check 0 and 6. And then internal critical points. Equal to 0. Let's see. Throw this away. X equal to 5. X equal -1. Are we going to use both of these? Are we going to test both of them? We're not testing this one. Why not? It's not in the interval that we need. So we only need to test 0 and 5, all right? So 0, 5, and 6. So just use hopefully if this is a calculator, just plug it into save that function in calculator and do f of 0, f of 5, and f of 6, and then that should give you the maximum value of it. Max. So the maximum value is at x equal to 0, and the maximum value is 0. The maximum value of f is equal to 0, and it is found at x equal to 0. Is this next sentence necessary? I don't know. Maybe doing too much here. It is the attained out of the 3. It is the what? Sometimes we complicate it more. This should be more than enough. It's already the maximum value of f. We've answered the question. What is this? It is the what? What the heck is it? What is it? What? It is the maximum value attained out of the 3 candidates. That's like not even necessary. I think this answered the question already. All right, determining concavity of functions over the domains. So there is that. So with concavity, and you have the position function, you would say, no, that f is the position function, and so how can we just like really in some way remember it without trying so hard as to when is it concave down and when is it concave up? The way I see it is basically if you have a circle, cut it in half like this. The top part is going to be concave down. This is going to be concave down. And pretty much is kind of thinking about throwing something up in the air, like a football. You got a football and it goes up in the air. It is always going to be concave down. So this is concave down. And then this one, let's use what color? Different color, I don't know. This one, the way I look at it, is that for those that know, like skating park, you go into the skating park, and then you get in there with your skate. So this one is concave up. So that's the way I'm gonna remember. So concave down is this concave down, concave up. What did somebody else say? Concave up. It holds water. The guy in the video said that this would be, it holds water. So if it rains, it can get flooded. It holds water, whereas the concave down cannot hold water. Whatever. That's what it is, no? So concave. So this one is concave. What? What is this? Concave down. This is concave down. Concave down means the second derivative, which is gravity. If we're talking about like a football, you got a football. You throw a football. Gravity is always pulling it down. It's negative. So concave down means that the second derivative is negative. The second part of this, again, like I just said, they connect here. This one also is going to be concave down. It means that the second derivative, or the acceleration, is also negative. Concave up, that's the last two. Those are going to be concave up. Then it means that the second derivative, the acceleration, is positive. Concave up means the second derivative, the acceleration, is positive. So now let's connect it to the first derivative. Maybe what that graph would look like. What is it doing? And the second derivative for each. And let's take a look at, so f of x in here, what is f of x doing here? What is the actual f of x doing here? For this first one, what is f of x doing? Because this is f of x. What is it doing? Is it going, is it increasing or is it decreasing? F of x is increasing. So f of x is, or is that what it wants? Is the f of x positive? Is that what it wants? Well, f of x is positive. The slopes are positive. The tangents are still positive, and the slopes are positive. They're still positive. So f of x is positive, but it's not talking about slopes. See, it's not talking. F of x is not talking about slopes. It's talking about the actual function. The function is increasing. So f of x is increasing, should be. So now this one's talking about the slopes. See, now this one, f prime of x, is what? And it's talking about the slopes at each point. So that's the slope there. And what is the slopes doing? What are the slopes doing here at every point? What are the actual slopes doing? F prime of x is the slope, and what are they doing? Well, they're definitely decreasing, because slope isn't this high? It's a slope. This is a higher slope. The slopes are decreasing. So the slopes are decreasing. Whereas if the slopes, yeah, so this is decreasing. And we already answered this question about the second derivative. Isn't the second derivative, well, actually, see, this is what I was trying, this is actually, what are the slopes doing? See, f prime of x, but since it's concave down, anything that is concave down is automatically it's negative. The acceleration is negative. So f prime of x is negative. F double prime of x is negative. It's less than 0. Yeah. Okay. Let's continue. Because we could have just answered this question something like f prime of x is positive. F prime of x is positive. They're always positive because that's true. Yeah, let's continue then. Yes, let's move on. Concave down, making it too complicated sometimes. Concave down, let's go to the next one. Concave down means the second derivative, acceleration is negative. F of x is doing what here? What is f of x doing here in this one? The function is what? What is the function doing here? The function is decreasing? Yeah. So the function is decreasing, the actual function is decreasing. F prime of x is what? What is f prime of x doing? The tangents, what are they doing? It's still the tangents. I'm trying to draw a tangent here. What are they doing? They're also what? What are they? What are they? Look, the slope is what? It's negative as it is, no? The slope is negative. See, we could say that f prime of x is negative. The slopes are negative. Whereas the slopes here are positive, no? Yeah? The slopes here are positive. The slopes here are negative. But for both of these, the slopes are what? Decreasing, aren't they? Aren't they? Yes? Depends on what is it that we want to focus on. If we want to focus on saying f prime of x, it is decreasing. And it's decreasing for both of these. These ones that is decreasing. So f prime of x is decreasing. F double prime of x is what? Negative. It's negative. We could just say f double prime of x is negative. So here's the very important takeaway here. You could even put a star next to it and say something like concave down means that the second derivative, concave down, what does concave down? Concave down means the second derivative is negative. That's what we already have here. Concave down means the second derivative is negative. We have it here. We have it here. Concave down means the second derivative is negative. Okay, concave down means the second derivative is negative. Concave up means the second derivative is positive. Anything that is concave up is positive. So we're saying in this situation, what? What is this? let's see. F of x is what here? Is it increasing or decreasing? What is it? Decreasing. F of x is decreasing. F of x is decreasing. F prime of x is doing what? What are the slopes doing? Yeah, let's go. What are the slopes doing? What are the slopes doing? Because that's what f prime of x is, the slope. What are the slopes doing? What are the slopes doing? Huh? Increasing. So whenever it turns, it's turning like this because they're increasing. The slopes are negative, no? The slopes are negative. The slopes are negative. But what they're doing, the slopes are increasing. The slopes are increasing, even though the slopes are negative, no? So f prime of x is increasing, and they are, and f prime of x is negative, but they are increasing. And f double prime of x is what? Positive or greater than 0. In this one situation here, this one situation, f of x is what? Is f of x is increasing, no? F double prime of x is, what are the tangents doing? What are the tangents at each point doing? They're also what? They're increasing. F prime of x is increasing. And the slopes are right there. All the slopes are positive. The slopes are positive and they're increasing. And f double prime of x is what? Greater than 0 or positive. Concave up is at the... Okay. So let's take a look at a graph, no? So we have an actual graph here, which is a third degree. Looks to be a third degree polynomial, maybe. So yeah, it's a third degree because it's just gonna go forever down and forever up there. So concave down, it will be concave down right here. See, this is concave down, and then it turns concave up. So the rate of change is, so for concave down, which is right here, no? This is concave down, all the way to some point here. So this is concave down. And now what are the slopes doing when it's concave down? We talked about, I'm using the, concave down, what are the slopes doing with concave down? The slopes are what? The rate of change is the slope, and they are decreasing. Concave down, the rate of change is decreasing. In other words, its first derivative, the velocity is what? In other words, first derivative velocity is what? The velocity is decreasing again. Is that what it wants? In other words, its first derivative, the velocity is decreasing. Concave down means what? The second derivative is what? Less than 0, it is negative. So concave down means the second derivative is less than 0. We're repeating everything. So what we just did before in the other one. The second derivative is less than 0. Then you have an inflection point where the slopes start going positive. You see, so let me see. Well, the slopes are going to start they start to increase. Start trying to increase. The slopes are. Even though here the slopes are negative, and then the slopes are positive over there, the slopes are there will be an inflection point, and then concave up means that the rate of change is what? It is not about positive or negatives, but it is that what? The rate of change is what? Increasing. Yes? Increasing. In other words, its first derivative velocity is increasing. Concave up means the second derivative is greater than zero, or it is positive. So what are these procedures for determining inflection points? So if we got to go to the second derivative, and then this becomes the critical point now. And now if you take the second derivative, and you're going to have to test points on the left and the right, and if they change signs, it's because it is an inflection point. But this becomes the critical point, no? So find inflection point candidates by setting the second derivative of the function equal to 0. So you're going to have to go all the way to the second derivative, set it equal to 0, find that critical point, then check for a change in sign of that second derivative at each candidate. If a change in sign occurs, then there is a point of inflection at that number. All right, moving on. Okay, problem 1. The continuous function f is defined on that closed interval from -5 to 5, including -5 and 5. Fill in the missing entries to describe the behavior of f prime and f double prime. If you wrote this down already, try not to look at your notebook and notes, and let's just kind of think about this. F of x from -5 to -2. From -5 to -2. F of x is doing what? What is that? What roof is? What is f of x doing? F of x doing? Increasing. It is increasing. Easy, yes, increasing. F of x is increasing. And from -2 to 0. From -2 to 0. Crystal, what is it doing from -2 to 0? Huh? Decreasing? Decreasing? From 0 to 3, what is f of x doing? Anybody? Increasing. And from 3 to 5 is what? Decreasing. So now, f prime of x, from -5 to -2, f prime of x, what are the slopes doing again? See, we're talking about what are the slopes doing. Take that one. Kind of going like that, and so you can see it already. You think about it, so f prime of x is okay. So now it's saying that the slopes are what? The slopes are positive. The slopes are positive, but they are what? Decreasing. Yes, does that make sense? So the slopes are positive, but they are decreasing. And on -2 to 0, the slopes are gonna be, so again, kind of think about it like that. So the slopes are what? Well, the slopes are what? -2 to 0. The slopes are what? Negative, and they are decreasing. From 0 to 3. What's going on from 0 to 3? the function is what? Is positive, no? The f prime of x, I mean. F prime of x is positive, yes? The slope is positive. And now, are they increasing or decreasing? This is constant. It's neither increasing or decreasing. So, it's neither increasing or decreasing. 3 to 5, the slopes are negative, and they are neither increasing or decreasing. F double prime of x. What is it? F double prime of x is what? From negative 5 to negative 2. Negative because it's concave down, no? Concave down is less than 0. Negative 2 to 0 is also concave down. The whole thing is, how about from 0 to 3? Does it, it's 0? The f double prime of x is 0? If I don't know, if you think about that, this is a line, no? This is a line that you can write an equation for this particular gray one. You can say it's y equals mx. The slope is what? Rise up what? 2 over 3? 2/3 x, and then plus 5. That's the equation of this one, no? And if you take the derivative, y prime, you're gonna get 2/3, no? And then y double prime, you get 0. You think about it like any line that would have no the acceleration is 0. All right, let's move on. Let's go to number 2. Find the intervals of concavity for this function. What do we need to do here? How many times? Second derivative? All the way to the second derivative? What did it say? What did it say? Concave. Where is it concave? Concavity, no? What did it say in what it said before? Look, let's go back. To find the interval concavity, this is concave down, and this is concave up. So you have to go all the way to what? Find the inflection point candidates, which would be those points, by setting the second derivative of the function equal to 0. Then you check for a change of signs. So we're talking about concavity here. You have to go all the way to the second derivative and then test. So that's what we have to do this for concavity. This is talking about concavity. Where is it concave up? Where is it concave down? So we have to go all the way to the second derivative. So f prime of x will be what? X to the third minus 12x squared plus 1. And then we have to go all the way to the second derivative. F double prime of x. That would be what? 3x squared minus 24x. That's it, no? And we set it equal to 0 to find those candidates for inflection points. What is that? 3x? And then it's going to be minus 12 equal to 0. 3x squared minus 12 equals 0. Then we're going to do what? Move it to the other side, 12. So it's going to be what? Plus or minus 2? All right. So these are the candidates for inflection points. So you want to do a number line here and put these candidates. So it's going to be negative 2 and 2. If now you're going to test the left and the right, the left, this interval, this interval, this interval. If there is a change of signs, then you could say that there's intervals of concavity there. This is f double prime. This is f double prime. So here's where we got our zeros. Let's test what? Negative 5? Negative 5. Where do we plug in that negative 5? We plug it into this f prime, no? We plug it into this function. Well, not that. This. So that's going to be positive. That's going to be positive, no? Yes. Quickly, that's going to be negative 5 squared is positive 25, 75 minus. This is a positive. This is positive. And then 0. We're going to test 0. If we plug in 0, that'll be negative. So there it is. And then we plug in what? 5. If we do 5, it will be positive. So there it is. When the second derivative is positive, is because it's concave what? Huh? Concave up. If the second derivative is positive, it's concave up, no? So that's going to be positive, so it's going to be concave up. On what? Concave up on negative infinity to negative infinity. Now, okay, to negative 2. Now, here's the question. Is it included or not included? Is it included or not included? And the answer to this is not included. Not included. Remember now from this, when it comes to this one, it will be not included, comma, 2 to infinity, not included. 2 to infinity. So when this is kind of confusing, because then when we're talking about increasing, we do include the endpoints, or whenever it's like where is it increasing? Something is increasing, and we say that it's included here or so. And then on the left side it was something like this. The graph was like this. It's weird why that is like that for increasing, that we include but not for concavity. So f of x is concave up on the interval, negative infinity to negative 2. Sometimes better, don't use u, just say from negative infinity to negative 2, and then comma, 2 to infinity. Union is fine, because f double prime of x is greater than 0. F of x is concave down on the interval, not including negative 2 to 2, because f double prime of x is less than 0. All right. All right, let's go to number 3. Given the following graphs, find the points of inflection and state the intervals of concavity. So it is, the most important thing is to understand what is it that you're given, which graph it is that you're given. This f prime of x is, you know that it's not the f, it's not the position function, but it's actually the velocity, if you want to think about it like that. So this is, let's think about it like this. That this is velocity, no? Let's see. Because it's a rate of change, actually. That's so. Having fun over there, Crystal? Rufus, is the velocity positive or negative right here?
Positive.
Yes, the velocity is positive. Is the velocity positive or negative right here?
Positive.
Positive. And the velocity here is what, Rufus?
0.
And the velocity is what here, Rufus?
Negative.
Yes. So we know that the velocities are positive on top and negative at the bottom. But now, what is the slope of this thing? What are the slopes? What are the slopes? What is the slope? What is the slope of this? Is it positive or negative? Negative. So when the slopes are negative, we're describing velocity. So the velocity is negative. And so when I'm talking about the slope of this thing, I'm talking about acceleration. So here, the acceleration here is negative. All the way to this point here. And here, the velocity here, I'll keep going with Rufus. What's the velocity here, Rufus? What's the velocity?
Negative.
The velocity is negative. The velocity is 0. The velocity is what? Positive. But what is the velocity? What is the slope of this thing?
Increasing.
It's increasing. Yes. All the way then to this point here. And then you got these other ones. So these become critical points. The critical points become, see, when we're looking at f function, when we're given an f function and we're asking for max and mins for f, not f prime, but f, and we're given a graph like this, we use this as a critical point. X is a critical point where the slope changes or something like that. Now it becomes kind of like that, but now these have become critical points here. This is a critical point. This is a critical point. And that's where these are the points of inflection here. This one, this one, this one. So given the following graphs, find the points of inflection, state the intervals of concavity. The points of inflection would be wherever it changes direction. So points of inflection would be x equals what? X equals what? Negative 1? X equals what? 1 and x equal to what? X equal to 2. F prime decreasing. F prime decreasing means F double prime is what? Less than 0? So that's where it's at. F double prime less than 0 means F is what? Concave what? Down on the interval. Therefore, F is concave down on what? Negative, not including negative 4, even though we don't include. So it'd be negative 4 to negative 1 and 1 to 2. F prime increasing means F double prime is greater than 0. F double prime greater than 0 means F is concave up on that interval, therefore F is concave up on negative 1 to 1 and then 2 to 3. Let's look at the F prime of X graph, an F prime of X, F double prime of X graph, which we're talking about that, let's say it's acceleration. I think this one is maybe a little harder, more difficult to understand. That one is straightforward. Where are the points of inflection? Well, where's the acceleration equal to 0? At which points is the acceleration equal to 0? Well, now these ones are going to be at negative 3 because acceleration. This is acceleration, and then there and there. No, this is more straightforward. No. Negative 3, 1, 3. F double prime is less than 0 means F is concave down on that interval. Therefore, F is concave down on where? Negative 3 to 1 and then comma 3 to infinity. F double prime is greater than 0 means F is concave up on that interval. Therefore, F is concave up on negative infinity to negative 3, 1 to 3. Okay, moving on. You guys go back, go get the notes if you need to. All right, let's go to number 4. The table gives values of a function f at selected values of x. If f is twice differentiable on the interval from 1 to 5, which of the following statements could be true? F Um, which was the answer? How do we figure this out? Basically, see. Let's do a quick slope of this. Let's do a slope of this. That's gonna be slope. I'll just put m for that part. M is gonna be what? 2 minus 1. I'm gonna go backwards. So it'll be 2 minus x goes at the top or the bottom? The bottom. It'll be what? 2 minus 1. 2 minus 1. And then it'll be what? 2 minus 1, I'm going like that. It'll be negative 1 minus a negative 6, which is going to be what? Plus plus. So this is going to be what? 5 over. So this is positive. The slope is positive. That did this right. Yeah. So it can't be A and B because F prime is not negative. It's going to either be C or D. Okay. So is it decreasing or increasing? So here the slope is 5. No, the slope is 5 here. Let's do this already. Let's do this. What is it? What is it going to do there? So M is going to be, the slope is going to be what? 8 minus 6. 8 minus 6. And then 5 minus 4. Which is going to be, slope is what? 1/2? Did I do this again? Did I mess up? F of x is on top. 8 minus 6. 8 minus 6. And then 8 minus 6 and 5 minus 4. So it's going to be what? It's 2, no? So it's positive, no? The slopes are positive, but what is the slopes doing? Decreasing. Let's just do this quickly. I don't know, just copy it down. This is the figure shows the graph of f prime. That is f prime. The derivative on negative 3 to positive 4. Find all x coordinates at which f has a relative max. Again, f prime. We're talking about f prime. This is velocity. Say this is velocity. So if that is velocity, so where does it have a relative max? At which point? Negative 2. And where else? That's it, no? That's it. Because it didn't change. You have to change the signs. Like right here is positive, right here is negative. And so the velocity was positive, so it's a max, no? Positive to negative. Whereas here, it was negative and it stayed negative. And so, on what open intervals contained is the graph of f both concave down and decreasing? Okay. On what open interval contained from negative 3 to 4 is the graph of f, not f prime, the graph of f, both concave down and decreasing, concave down. So where is it concave down? Where is concave down? This is f prime. And where is it concave down? Negative what? Negative 3? Isn't it concave down when the slopes are negative? Concave down? So now, that's concave down. And where is it decreasing? Concave down and decreasing. Where is the decreasing? You guys remember? It's talking about f. Where is something concave down decreasing? If you remember that these are the options, no? That one, and that's it. That's going to be one of these because it's not going to be this and this, no? Because this is concave up and concave up, no? So it's going to be one of these. So this is concave down and decreasing. So we're looking at this. Where would the graph be doing that? Where is the graph doing that? Where are the slopes? What are the slopes doing here? What are the slopes? What are the slopes doing here? What are the slopes doing here? They're going down, no? And what are the slopes doing here? They're also going. Both of these are concave down and decreasing.
Isn't it talking about F though?
About F. Okay. Okay. So it wouldn't be this?
It would be the same.
It'll be the second one. So what? Which one is it then?
-2 to -1.
-2 to -1? Why is that? Because
Slope is negative.
the slopes are negative.
But the slope for F is negative.
Okay, yeah. All right. Let's see what we got here. Oh, and also the other one. The one over there. Find the x coordinates of all points. Find the x coordinates of all points of inflection. Where are the points of inflection at? Where are the points of inflection? Is that this? This? And this? It has to change signs. Okay, good enough. That's it. We're done.